Coming on to the antennas applications, every antenna is having their own application, and further, what are the sectors in which antennas are used that I have mentioned, and not all I have mentioned, but the broad category I wanted to take, so that I have mentioned. So first of all, we all need data in mobiles also. So you can think of as electronic gadgets, in which it can be your smart TV, your smartwatch, your laptop, your phone, anything it can be. And further, then cell tower for the base station antennas and all, it will be required to route your message signal to the desired location. And then for further wireless communication and anything else, it can be like Bluetooth antenna, your Wi-Fi router, anything. Then further defense application, in defense application also, like radar communication, at that time also it will be having a antenna. Then satellite communication, in order to send the satellite signal, like if you're having live streaming of your any match, either soccer match or cricket match, then it will be because of your satellite communication. So these are all the broad areas in which antennas are required, and that's why I used to think that wireless communication means antenna, because alternative to antenna, I can't think so that it will be any other alternative can be made or invented, which is having such a simplest modeling and analyzing, along with a huge performance. Okay, then further, I'll come to the band nomenclature. So band nomenclature means what all the range of frequencies have been given as a designation, and a name, a letter, or you can say, has been allotted to that. So I'll start with the 3 to 30 megahertz, that is comes under the high frequency, that is HF. 30 megahertz to 300 megahertz means VHF, that is very high frequency. Then further, 300 megahertz to 1 gigahertz comes under the ultra high frequency, and then further LS band, C band, X band, KU band, or you, sometimes it will say Q band, then K band, K band, and V band, W band, and G band. So sometimes this is, anyway, this is nomenclature is for standard IEEE standard 521 2002. Anyway, the new conventional nomenclature has also been come, where E band, Q band are there, so that also you can go through. But anyway, whatever the conventional, and still it has been used by most of the organization, application, and so on. So that's why I have considered this standard nomenclature, and LSC band, X band, Q band, K band, K band, V band, W band, and G band. Okay, so mainly K band 27 gigahertz to 40 gigahertz, like one of the range for 5G communication, or you can say in which 28 gigahertz, and some of the frequencies 26.5 and 28 gigahertz are for or 5G communication. Okay, now further, again, this this convention I've used based on the ITU, that is International Telecommunication Union. In the previous slide, which I have mentioned, is based on IEEE standard, which was based on 5251 on 521 on 2002. Okay, so this is based on the ITU radio bands Article 2, provision number 2.1. So in this also I have mentioned band description and the frequency range. So that is, description means nothing but the abbreviation for each of the terms, which is ELF, SLF, ULF, VLF, that is very low frequency, ultra high frequency, and super low frequency. Like that, it will goes to LF, MF, that is low frequency, medium frequency, high frequency, VHF. Okay, so VHF. Okay, and further SHF comes to the SHF comes to the super high frequency from 3 to 30 gigahertz. Okay, and EHF means extremely high frequency. Then further, THF is tremendously high frequency. Anyway, this exahertz like range you have heard of, so that I have mentioned already from 300 to 3000 gigahertz. Okay, then further in that I will, if I'll say that exahertz is also a part of terahertz communication. So means not terahertz, but it will come after the this 120 gigahertz. So that time terahertz communication will take place. Means 10 to power 12 terahertz. Okay. Then further, one image I wanted to show, which was based on the antenna only. Anyway, it is a very rough diagram, not at all having a very clear meaning. So that I just wanted to know, just wanted to tell that whatever antenna we are using, it is having a lots of antennas embedded in it just for Wi-Fi, Bluetooth, GPS, okay, and then CDMA, PCS, like for wireless communication means for calling purpose. CDMA is having a band of 980, if I'm not wrong, 98 GSM 900, GSM 1800, like that. If you have heard, then you might know that it has code division multiple SS. Okay, and then further the polarization means polarization at what the vector, the field vector at what it has to be oriented, that so that your waves will travel in that way only. So that is also one kind of a part, and this polarization is very very crucial in terms of your determination of whether your receiver antenna will able to recept, or you can say receive those signals or not. Like suppose in case of your receiver antenna is having a linear polarization, and that too horizontal polarized, but your receiver antenna is having a vertical polarized antenna, then it will not able to receive that signal because there is a mismatch in the polarization. So that's why nowadays you might have known that circular polarization is very much in trend, like RHCP and LSCP, that is right hand circular polarization and left hand circular polarization. Okay, so these are the some key aspects I wanted to explain you guys. Then coming on to the next thing is frequency based applications. That is, what are the applications are available and what is the frequency range used for it. That is CDMA, suppose code division multiple access is used from 1824 to 824 to 890 megahertz. And for the GSM 900, GSM 1800 used for this, some two bands are allocated for each of the application, that is 890 to 915 and then 935 to 960 megahertz. Now sometimes this band gap is there in between, suppose 20 megahertz, just to avoid the overlapping. Okay, just to avoid the overlapping and interference, suppose of interference, because in order to go for sampling, then if you have heard about if you have remember your graduate subjects that time, signal and systems, or I don't know what kind of name of at that time in your case, but in case of signal system, that if you're sampling and then truncating your signal, means that part you want to trunk, then it your spectrum will get spread. Okay, so it is not necessary that it will lie in your specified range only. It can definitely, it is very very much probability, it is very high probability that it will go high, beyond your frequency limit. Okay, so that's why sometimes in between the two applications the frequency gap should be there. Then further, GPS means global positioning system or satellite, anything it can be. So it is having a 1575 plus minus 10 megahertz, that is 1.57542 gigahertz, I will say. Okay, and then further 3G and 4G, it is also having a frequency of 1920 to 1980 megahertz. So mainly this frequency I have told you, so that in order to start your designing hands-on with the tool, you can take any of the frequency based on these applications and that application, any kind of a, and you can design it and analyze it, what are the gains acceptable for that communication. So, and you try to match those kind of parameters specified for the application for which you are designing, so that and that too some unique antenna, if you're unique design, if you are designing, then it will be a very very good for you to showcase in some repeated conference and repeated work. Okay. Then further, Wi-Fi is also 2.45 and 5.2, 5 gigahertz, 5.8. So many bands are available, which is comes under IEEE 802.11 protocol, or you can say standard for that. Then for the satellite and defense communication also, it will come around HF around 200 megahertz to 2 gigahertz. Sometimes military applications will come this. Regarding the radar application will comes under 12 gigahertz to 16 gigahertz also. Then further, if I talk about this 5G, that is fifth generation, then fifth generation, if I'll say, then it has already I told that it lies in a K band, that is 27 to 40 gigahertz, in which 26.5 and then further 28, 28, then 36 and 38 even. Sometimes these bands are allocated for the 5G communication. Then if you goes to the high frequency, suppose 60 gigahertz. So 60 gigahertz also some people will consider for this 5G. Some people will consider a terahertz communication. Then but in my opinion, it will be comes under the 5G on, because most of the research manuscripts and the articles have been a very good evidence for this frequency which is applicable for the 5G communication. Okay. Now I'll come to the antenna mechanism. Now antenna mechanism, anyway, in this course I'm not considering the types of antennas. Types of antennas I've already included in my first course, which was antenna designing theory to practical. You can check in my website as well. So the basic type of antennas amongst all antennas are considered to be the dipole antenna. Now dipole antenna is nothing but a wire only, or you can say it's something having a wire which is having some cross sectional area and having some length as L. So in that case this mechanism is different. Okay, so that's why in standard books, if you are taking about standard books of Thomas A. Milligan and anyway the Balanis book, in that two mechanism will be there. Some mechanism will be there for the antenna. First will be your wire antenna, or you can say the dipole antenna, for in order to understand the mechanism for the wires. Okay, so further, two wire mechanism is also important, and anyway two wire mechanism only I will going to explain in this course. Okay, but before that, what are the conditions which are required for the radiation in order to exist? That condition also I have mentioned here. And further, this radiation means whenever this charge are moving, dq by dt is nothing but your current only. So if charges are not moving, that means no current, hence no radiation. Then further, if charges means dq by dt is having a constant value, so then two cases will be there. If conductor is straight, means whatever the conductor in which the charges are flowing, it is straight, means continuous, no alterations are there, then there will be no radiation. But further, if a conductor is bent or somewhat altered, suppose truncated, terminated like that, then it will be having a radiation, because charges at that time will accelerate, deaccelerate. Mainly the thing is, you have to accelerate the charges, accelerate or deaccelerate the charges in order to have a propagation of the radiation. Okay, then further, when the charges are oscillating, means in a sinusoidal wave or or cosine wave, then also even if the conductor is straight, then also this radiation will occur. Okay, then further I will say thus that consider this diagram for source, antenna, and transmission line. Transmission lines in mean nothing but the where this antennas will propagate. Okay, that's why this wave has I have mentioned here. And anyway, this image you can see as well as in Balanese book also, because these are the books which are very very standard or very basics for antennas. So that's why I have taken this standard book reference only, because anyone, if you're going, because after this course, if anyone is going for reading the standard books, then it will be easier for him or her, so in order to understand the concepts. So I'll continue in the next lecture.